following function describes the motion of an arrow shot upwards. The height h is in meters after time t in seconds. H of t is equal to negative 5t squared plus 40t plus 2. Find the maximum height reached by the arrow. What is the impact velocity of the arrow when it hits the ground? Okay, so to find the maximum height of the arrow, what we want to do is when the velocity of the arrow hits 0, we basically have a maximum height. Okay, and we can figure out if we set the velocity function to 0 and we solve for time, then we can basically find t max, right? So this value here would be the maximum, the time it takes to get to the maximum height. Okay, so time it takes to get to the maximum height. So right now we have the position function. H of t is just position on the y-axis because we're basically moving up or down. And if we want to find a velocity function, it's the first derivative of h of t. So we're doing h prime of t, which is equal to the derivative with respect to the rate of change of time of negative 5t squared plus 40t plus 2. And in this case, the velocity function, the derivative of negative 5t squared is negative 10t plus the derivative of 40t is 40. And we want to let the velocity function equal 0. And we're doing this because when the velocity function is 0, the object is temporarily at rest, and it also enters its maximum height. We want to solve for the time it takes to get to the maximum height, so I'm going to solve this equation. Negative 10t plus 40 is equal to 0. I'm going to move the 40 to the other side. Negative 10t is equal to negative 40. I'm going to solve for t, so I'm going to divide this by negative 10. I'm going to do the same thing to the right side. And in this case, t is equal to 4 seconds. Okay, so at 4 seconds, the object will reach is maximum height, but we want to figure out what the maximum height is that it reaches, right? So what we need to do, we plug this back into our height function. So if we plug it into our height function, we're doing h of 4 is equal to negative 5 times 4 squared plus 40 times 4 plus 2. And if I calculate this, you get negative 5 times 16 plus 160 plus 2, and this gives me 82 meters. Okay, so h of 4 is 82, and that means that the maximum height occurs at 4 seconds, and the maximum height is 82 meters. Okay, so we know that the maximum height is 82 meters. What is the impact velocity of the arrow when it hits the ground? Okay, so if we're looking at when the arrow hits the ground, I'm just going to change colors so we can look at the next question. Question B, right? Well, we need to figure out the time it takes for the object to hit the ground. We do have the velocity function, so after we find the time, we're going to plug it into this function. So if we want to find the time it takes to hit the ground, I'm going to let h of t equals 0, right? That's the height when the object is at the ground. And we get negative 5t squared plus 40t plus 2 is equal to 0, right? I want to solve for t. For this case, you can actually just use the quadratic formula, right? So t is equal to negative b plus minus b squared minus 4ac over 2a, right? So in this case, the values of t that I would have gotten here by plugging into this equation are negative 40 plus minus b squared is 40 squared minus 4 times ac, so 4 times negative 5 times 2 over 2 times negative 5. Okay, so if you punch this out, you're going to get two values, which are, so t is equal to negative 0.04969 seconds as well as 8.0496. Because t has to be greater or equal to 0, we can't include this value, so I'm just going to be looking at the 8.0496. I'm going to round that to 8.05 seconds. And if you want to find, so this is the time it takes for the arrow to hit the ground. So if you want to find the velocity of how fast the arrow hits the ground, the impact velocity, I'm going to plug this into the velocity function. So you're doing v of 8.05 is equal to negative 10, 8.05 plus 40, which is equal to and this is going to give us negative 40.5 meters per second. Okay, so this is your impact velocity and occurs at 8.05 seconds, right? And the negative just implies that the object of the arrow, the direction of the arrow is moving downwards, right? So if a positive sign implies that the object is moving up, negative sign would just mean that it's going down. Okay, so the impact velocity here is negative 40.5 meters per second, or you can just say 40.5 meters per second.